Hi, I'm Miss Cho, and in this video we'll talk about polynomial factors and the remainder theorem. Before we talk about polynomial factors, let's look at factors numerically. When I say that 7 is a factor of 63, what does that mean? It means that I can take 7, multiply it by some number, a whole number, and get 63. So I know that number is 9, but if I didn't know what it was, I could take the 63 and divide it by 7 to give me 9. And so if I wanted to know if 7 was a factor of 481, I could just do the same thing. I could take the 481 and divide it by 7 and see if it divides evenly. I'm going to pause the video to work it out. So as you can see, I have a remainder of 5, which means that 481 did not divide evenly into 7 groups. There were 5 left over that couldn't be formed into a group of 7. So that tells me 7 is not a factor of 481 because the remainder is not 0. The same thing applies to polynomials. Let's take a look at an example. In this example, we're asked, is x minus 4 a factor of p of x is equal to negative 3x cubed plus 17x squared minus 16x minus 16? So what I want to know is, can I multiply x minus 4 by something and get p of x? I don't know, so I could find out by dividing both sides by x minus 4 and see what I get. So I'm going to set this up as my long division. You can use synthetic division if you prefer. And if you don't remember how to do either of those, please check out my videos above. I'm going to pause this video so that I can work it out, and then we'll talk about the results. Since my remainder here is 0, that means that my polynomial divided evenly into the x minus 4 groups, which means x minus 4 is a factor of p of x because the remainder is 0. Let's take a look at a second example. In this example, we are asked, is x plus 3 a factor of p of x equals 2x cubed minus 4x squared minus 23x plus 36? So again, the question is, can I multiply x plus 3 times something to give me p of x? And to find that out, I'm going to do this by long division. You can use synthetic division if you prefer, but I'm going to do this by long division, and I'm going to pause the video so that we can talk about the results. So as you can see here, my remainder is 15. That means that I could not divide my polynomial p of x into even groups of x plus 3, and I have 15 left over. This means that x plus 3 is not a factor because the remainder is not 0. If division is something that's challenging for you, there is actually another way to find the remainder without dividing, and that's by using something called the remainder theorem. So what the remainder theorem says is if you're dividing a polynomial p of x by a linear divisor, x minus a, the remainder will be p of a. What does this mean? Let's break it down. A linear divisor means that the highest exponent of your divisor is 1. You cannot have an x squared, x cubed, or anything in your divisor. It has to be x to the first power. This a here, this is your 0 of your divisor. So if your divisor is 2x minus 1, then the 0 is the value of x that makes this expression 0. So that means I set it equal to 0 and solve for x. So here I'm going to add 1 to both sides, and then I divide each side by 2, and my x is equal to 1/2. So this would be my a that I substitute, and this a is also what you would use in synthetic division. Looking back at our example 2, is x plus 3 a factor of p of x is equal to 2x squared minus 4x squared minus 23x plus 36. So what I want to do is find the 0 of x plus 3. It is linear because there's no exponent on the x. And then I take away 3 from each side, and I get x equals negative 3 as my a. So this is my a. And what I want to do is plug in now this negative 3, x. And so find p of negative 3, which means I'm going to plug in negative 3 everywhere there's an x. So this is minus negative 3 squared minus 23 times negative 3 plus 36. And this 15 is the remainder, which we found when we divided by long division. Why does this work? The reason why this works is because we can rewrite our dividend as a divisor times your quotient plus the remainder. So in numbers, if I had 25 divided by 4, this is, when I work this out, I get 6 and the remainder of 1. If I wanted to change 6 and a 4 to a mixed number, I would multiply the 6 and the 4, and I would add the remainder. So what this means is 25 is equal to the 6, the 4 times the 6 plus the 1. And you can see that's true. 4 times 6 is 24, plus 1 is 25. The same thing is true of polynomials. I'm going to rewrite our problem so that we have all of our parts. So from our example 2, our polynomial was this 2x cubed minus 4x squared minus 23x plus 36. When we divided by x plus 3, we got a quotient of 2x squared minus 10x plus 7, and our remainder was 15. So what happens when I plug in p of -3 for x? So on the right side, I'm going to put in my -3 here, and then I'm going to leave this just as is, just for simplicity's sake. So when I have -3 plus 3 here, this becomes 0. And I have 0 times my quotient plus 15, and 0 times anything is automatically 0. So this means this is 0 plus 15, or my remainder, which means your remainder is the only thing that you have left. So that's why this is always true, that if you plug in the 0 of your divisor in place of x, all that will be left will be your remainder. Let's summarize. Factors divide evenly into the dividend, and by divide evenly, I mean that the remainder is 0. If you want to know if something is a factor, you can divide and find the remainder. If your remainder is 0, then it is a factor. If your remainder is not 0, it is not a factor. If you don't want to divide, you can use the remainder theorem. So that means if you plug in the 0 of a linear divisor into p of x, so you find the p of your 0, the result that you have left will be your remainder.